Have you ever stood at a crossroads feeling the weight of the choices before you? Have you ever wondered about the roads not taken, the paths that disappeared behind you with each step forward? Imagine that somewhere, perhaps not so far away, another you made a different choice, a choice that led to a completely different life. A life where your dreams took flight in ways you never thought possible. Maybe in that other reality, you're sipping coffee instead of tea, or perhaps you decided to skip the caffeine altogether and opted for a refreshing glass of juice. Or maybe you're taking a different route to work, a scenic detour that allows you to appreciate the beauty of the world around you, a route that sparks joy and inspiration. What if, in another world, your life branched off in that tiny moment, that seemingly insignificant decision that altered the course of your destiny? This isn't just the stuff of science fiction, the realm of fantastical stories and imaginative worlds. It's a real idea, a concept emerging from the forefront of modern physics, the tantalizing possibility of the multiverse. Our universe, with its billions of galaxies, each containing billions of stars and planets, could be just one bubble, a single entity, in a vast cosmic ocean filled with an infinite number of other universes, each with its own unique properties. Each universe might have its own fundamental laws of physics, governing everything from the behavior of particles to the formation of galaxies. Its own unique history, shaped by different events and circumstances, leading to vastly different outcomes, and perhaps most intriguingly, its own versions of you, living lives that diverge from your own in countless ways. Some worlds might be almost identical to ours, mirroring our own existence with subtle variations. Others could be unimaginably different, governed by laws and principles we can scarcely comprehend. The multiverse theory suggests that every choice you make, every decision you face, every random event that occurs, every unpredictable moment, could create a new branch of reality, a new universe where that choice or event played out differently. Scientists are using the language of physics, the tools of mathematics, to explore whether these other worlds could genuinely exist, to find evidence that supports the existence of the multiverse. As we dive deeper into this fascinating subject, we'll explore how these mind-bending ideas emerged, tracing their roots back to the pioneers of quantum physics. We'll examine what kinds of parallel universes might be out there, from those governed by different physical laws to those that are nearly identical to our own. And we'll investigate how researchers are searching for evidence using cutting-edge technology and innovative experiments to unlock the secrets of the cosmos. Get ready to have your perception of reality stretched and expanded, to question everything you thought you knew about the universe and your place within it. So, what is a parallel universe? At its core, it's the idea that our universe is just one of many. Imagine each universe as a page in a cosmic book, each with its own space, time, and matter existing independently. The multiverse isn't a single theory but a consequence of several areas of physics, from quantum mechanics to cosmology. Sometimes the math suggests it's easier to create many universes than just one. Some theories place other universes in different dimensions, others in distant regions of space, and some suggest new universes branch off with every quantum event. These universes could be nearly identical to ours or wildly different, with their own physical laws. The common thread: our universe may be just a small part of a much larger, more complex reality. It reframes our cosmic address from the universe to a universe. The multiverse journey, a concept once relegated to the realms of science fiction, actually began with the very real and tangible science of quantum mechanics. It's a field that explores the bizarre and often counterintuitive behavior of matter and energy at the atomic and subatomic levels. In the 1950s, a brilliant mind named Hugh Everett dared to challenge conventional wisdom. He proposed the many worlds interpretation, a radical idea suggesting that every quantum event, every single decision at the smallest level splits reality, creating parallel universes for each possible outcome. Imagine a coin flip. In one universe it's heads, in another tails. Both are real, both exist simultaneously. Initially dismissed by many in the scientific community, Everett's idea lingered in the background, a seed of possibility waiting for the right conditions to sprout. It was considered too strange, too philosophical, and not grounded enough in observable reality. Then, in the 1980s, Andre Linde's theory of eternal inflation emerged, adding another layer to the multiverse concept. Linde suggested our universe is not unique, but just one bubble in a constantly expanding cosmic foam, a vast and dynamic multiverse with new universes, each potentially with its own laws of physics, forming all the time. It's a mind-boggling picture of continuous creation on a scale we can barely comprehend. These two seemingly disparate ideas, quantum branching at the smallest scales and cosmic inflation at the largest, set the stage for modern multiverse theory, providing a framework for understanding how multiple universes might arise. Physicist Max Tegmark later took these concepts and organized them into a hierarchy of 4 distinct multiverse levels, bringing a sense of order to the seemingly chaotic landscape of multiverse theories. He was instrumental in clarifying that not all parallel universe ideas are the same, and that they arise from different physical theories with varying degrees of testability. Everett gave us branching realities, a universe constantly forking into countless possibilities. Linda gave us bubble universes, an infinite expanse of cosmic domains, each a universe in its own right, and Tegmark gave us a map, a framework to navigate them, helping us understand the different types of multiverses that might exist. These scientists weren't writing science fiction for entertainment, they were rigorously following the logic of their equations, pushing the boundaries of our understanding of the cosmos. Their work opened a new frontier in our quest to understand reality, forcing us to confront the possibility that our universe is just a small part of something much, much larger. The multiverse is now a serious topic of investigation in physics, not just a wild speculation confined to the fringes of science. It challenges us to ask a fundamental question: what if reality is far bigger, far more complex, and far more diverse than we ever imagined? The journey continues, and the adventure is just beginning, as we delve deeper to explore the different levels of the multiverse and their implications. Let's see what each level means for our understanding of existence and how they challenge our fundamental assumptions about the nature of reality itself. Max Tegmark, a renowned physicist, has proposed a fascinating classification system. This system helps us understand the different types of parallel universes that might exist, each with its own unique properties and characteristics. It's a framework for exploring the vast possibilities beyond our own observable universe. Level 1. In an infinite universe, which is a key concept in Level 1, every possible arrangement of particles exists somewhere. This is due to the sheer size and scope of infinity. Meaning there could be exact copies of you living out slightly different lives unimaginably far away in the vast expanse of space. These copies arise simply from the statistical probability within an infinite cosmos. Level 2, eternal inflation, a theoretical extension of the Big Bang, creates countless bubble universes, each potentially isolated from our own. These bubble universes may have each with different physical constants, governing the way matter and energy interact. Most are lifeless, due to inhospitable conditions, but some like ours, are just right for life, existing within a Goldilocks zone of physical laws. Level 3 Everett's many worlds interpretation of quantum mechanics. Every quantum event, at the smallest scales of reality, splits reality, creating parallel branches, each representing a different possible outcome. This implies that countless versions of you live out every possible outcome, in branching realities constantly diverging from each other. Level 4. The mathematical universe hypothesis, a bold and profound concept. It posits that anything mathematically possible is physically real. Universes with fundamentally different laws of physics, alternate dimensions, and exotic realities beyond our current imagination. Each level expands our view of what's possible, pushing the boundaries of our understanding of existence. Some are extensions of current theories in physics and cosmology. Others are deeply speculative, venturing into the realm of theoretical speculation and cutting-edge science. Together, they form a grand vision. Reality may be far more vast and varied, holding infinite possibilities than we ever dreamed possible within our limited perspective. The multiverse isn't just one monolithic idea, it's a spectrum of possibilities, encompassing a wide range of theories and diverse concepts. Each level raises new questions, forcing us to reconsider our place in the cosmos and grapple with profound existential questions. As we move up the hierarchy, the possibilities become stranger and more abstract, challenging our intuitive understanding of the universe. But all share one unifying message. Our universe, with all its wonders, may not be alone in the grand cosmic tapestry. The cosmic hierarchy invites us to imagine realities far beyond our own, opening our minds to transcendent possibilities and the sheer scale of existence. The multiverse is a bold idea, but is there any evidence? Scientists search for clues in the cosmic microwave background, the afterglow of the Big Bang. A collision with another universe might leave a strange mark like a cold spot or hot spot. Some theories predict gravity could leak between universes, and experiments at the Large Hadron Collider might reveal hints, like tiny black holes evaporating in unexpected ways. Quantum computing offers another angle. Some argue its power comes from tapping into parallel realities. But all these searches are long shots, and any evidence would be indirect and hotly debated. By their nature, parallel universes are separate from ours, making direct proof elusive. Still, the quest continues, pushing the limits of technology and imagination. The potential reward, proving we're just one of many realities, drives scientists to keep looking. The multiverse theory is one of the most divisive ideas in physics. Supporters see it as a natural extension of our best theories, explaining puzzles like why our universe is so perfectly tuned for life. It's the next step in decentering humanity, suggesting even our universe isn't unique. Critics argue the multiverse isn't science if it can't be tested or falsified. If other universes are forever out of reach, does the idea belong in physics or philosophy? Some worry it's an easy way out, explaining everything by saying all possibilities exist somewhere. The debate is fierce, reflecting a deeper question: what should science be? Should we explore bold ideas even if they're hard to test? The multiverse forces us to rethink the boundaries of scientific inquiry. Traveling between parallel universes is a staple of science fiction, but could it ever be real? According to current physics, the answer is almost certainly no. In Level 1, other universes are so far away we could never reach them. Level 2 bubbles are self-contained, with no bridge between them. Level 3 branches are in different quantum states, forever sealed off from each other. The barriers aren't just technological, they're woven into the laws of reality. Scientists aren't building multiverse portals because our theories give us no reason to think it's possible. The multiverse, if it exists, is a set of parallel stories we can never visit. Our exploration remains in the realm of mathematics, philosophy, and imagination. If the multiverse is real, it raises profound questions about identity and choice. If countless versions of you exist, what does it mean to be you? Are you unique or just one of many? If every choice creates a new branch, did you really choose it all? This challenges our sense of free will and responsibility. The multiverse also redefines our place in the cosmos. We're not the center of a single story, but one character in an infinite ensemble. It's humbling, even unsettling, but also inspiring. As science explores these questions, philosophy and ethics must keep pace. The multiverse doesn't just challenge our science, it challenges our understanding of what it means to be human. The multiverse stands at the edge of science, where theory, observation, and philosophy meet. Physicists will keep refining their models, searching for predictions that can be tested. New telescopes and particle colliders will hunt for the tiniest clues, anomalies that might hint at other realities. The pursuit itself pushes our knowledge and technology forward. We must also be open to being wrong. Science is about following the evidence, not clinging to ideas. Whether the multiverse is real or not, exploring it has already expanded our imagination and deepened our sense of wonder. It reminds us how much we don't know, and how much there is still to discover. The greatest mysteries may lie just beyond our current understanding. So next time you look at the night sky, wonder not just about the stars you see, but about the infinite other skies, and the infinite other yous, who might be wondering too. The journey to understand reality is far from over.